Alright, so half space is gonna be, if we have some sort of plane, any plane and just have something shaded above or below it, we're talking about half space. Well, all of these are planes. Anything z is greater than equal to z, excuse me, we're strictly greater than 0, x and y, so you were looking at all of the above for that one. If we were saying the red one, z is greater than 0, nothing says you have to split space up and down. You can split it side to side, left to right.
Hey, I'll talk about.
Y equals 3 is just a plane parallel to the what plane?
X and Z. Ew. Yep. Wow. All right, man. Oh shoot. Oh, it's gonna be. Oh, damn it.
Alright, so this one, x squared plus y squared is less than or equal to 1. So y squared plus z squared equals 1 is a cylinder, but nothing shaded in. Because it's less than or equal to, it is shaded in. So I'm personally torn between these two that are shaded in. The only thing I have to ask myself is what axis does it open along? Because x isn't mentioned in there. X is free, so it's going to open along the x-axis. So we're looking at that choice.
Wow.
Alright, this is where we're standing right now. So, help me out. Alexa and Alexa.
I'm Alexa and she's Alex.
I just wrote Alex 3 times.
Oh, I thought it was, I see.
Ooh. What is that so, C is, I don't know about that one.
why is it
Oh, different coefficients.
not number 1?
I don't even.
Or I guess the red one,
Is it because it's on the same coefficients that makes it a sphere?
which would make it a sphere, yes.
Yeah.
Why is it not another one that we could have thought it was, well I guess these are the same, right? Just different radio. Oh no, this isn't squared in Y. Alright, let's see where we stand with the points. Alright, Alexa, Chloe, Julie, those are your top 3.
I'm not even okay. So it's gonna be. Oh shoot. Oh, so that's the seconds we have. Okay.
Sweet.
Oh damn. Okay, everybody got it. Yay.
So the cones, opening up on its side like this. So if you were to slice it this way, you're gonna hit both of these pieces, so you get two parabolas, so you get a hyperbola. Ooh,
Yeah.
Ooh. Okay. Oh, that's ill. What is that? It's gonna be.
What, oh, and look at this.
Less than or equal to.
so while everyone got it right, some people didn't key in, so it's a sphere below my xy plane. So all my z values need to be less than or equal to 0. So I'm looking for some sort of restriction because it's not the entire sphere. It ends up not even mattering what the radius is, I just want something below that xy plane.
Ew. Hmm. Describe. Oh, that's not you. Hold on.
Alright, that's definitely worth talking about. So x squared plus y squared plus z squared equals 16. If I want to see the trace or the intersection with z equals 10, what can I do algebraically?
You know the radius is 4 of that because it's r squared.
Oh yeah, you're already thinking about it, just what geometrically does this look like? It's a sphere with radius 4, but this plane is at 10.
10.
So there is no intersection. How could you see it algebraically if maybe we're having a hard time visualizing these? You can just plug in z equals 10.
10, yeah.
What's 16 minus 100?
-84.
You've got x squared plus y squared equals, a negative. We can't have that. So this is showing that this isn't going to represent anything. And if we're wondering, I just keep saying can't have a negative. Why? When you square something, you have to get something non-negative. So something squared plus something squared should also be something not negative. So when I get a negative, I know that can't. But yes, you also could have thought of this visually. This is a sphere with radius 4. Well, if I'm drawing a plane at 10, I'm not going to touch the sphere at all.
Right. What? Oh,
So the 2-sheet one is quite literally split into 2 pieces. No one fell for the hyperbola, but that's a 2-dimensional figure.
Wait, what is it?
That's when it's split into 2 branches. There's no connection between the 2.
Oh, okay.
now you gotta reconnect. Okay, yeah.
Why is it not the blue one?
Because it's
They
with
said
that.
those signs.
Cause there's mismatched signs. I think I like that the best, instead of saying one's negative, like there are mismatched signs here. But looking at the red, hang on, you just told me that it can't be negative.
But you
But if I multiply the entire thing by a negative, now I've got that positive, 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 positive. So I'm clear.
network is slow, so you might experience basically. Okay, we go. That is. I said, come on, though. Come. I didn't get half going to. Is it? It is the longest one. Dude, she I don't know my Wi-Fi exactly.
Alright. So I knew we'd be split between the two of these. Don't forget, that cone that we all know and love, an ice cream cone, that is only a half cone. So a cone is actually the two pieces together. So if we put cone, we fell for it. Half cone is just the one piece that we're familiar with.
Half cone, one piece. Okay. Intersection, two planes. As far as intersection. Oh, intersection. Intersection.
You have two planes that intersect, you get a line.
Okay. Okay. The distance from. Oh, okay. XC. That's easy.
So if I want the distance from the XZ plane, that's how far I went in the Y direction.
Yeah.
So it's -3, right?
It's absolute value.
Oh, it's the distance.
Absolute value.
Distance can't be negative. I felt for it.
Wow.
Alright, so we're gonna have 16, 17, 18, 19, 20. We're in the final 5 questions.
It's comeback time.
Okay. Oops.
Oh, a sphere is an ellipsoid. A sphere is an ellipsoid. It is the special case where all of the axes are the same.
Right.
So we might have looked at that and go, oh, that's not, but it is. Alright, so the majority were in the wrong this time, so I'm very interested to see the score change this time.
I'm too far behind to be going anywhere. Two. Two. Oh. Hey. The guy is struggling.
Cool. same technique as this one, x squared plus y squared plus z squared equals 10. But now I'm just gonna substitute y as 1.
Right, and then it'll be 9. It will be reduced 9.
And then I subtract 1 from both sides.
Wow.
I get x squared plus z squared equals 9. So we're looking at a circle.
Wow. Circle. Radius 9. It's not a quadratic surface. Okay. I don't know what that is. So the one that you don't know what it is. What is that? I think. I hope.
Oh my god.
Yeah, just in case, does anyone know what a torus is? It's a donut. Okay. So that would be a torus. And we can talk about the number of holes in a donut, so you can have like a genus 1 torus. If you had the same thing, you had a donut over here, there would be a genus 2 torus. All right, let's see the final score counter at the end.
Wow, nice.
And 2 points on exam 1. There. All right, so the next thing for us to talk about today, I think I have it on the topics list that it's introduction to vectors. I think it's more gonna be like a review of vectors. We've seen vectors before, right? So this will just be a very quick review, nothing too intense, ready to start working with actual vectors next week.
Oh.
All right, so starting to think about vectors. So we have a vector that has both a quote-unquote magnitude and a direction. So if this was the vector A comma B, and just a quick note, there are lots of different ways that you can write this, and I'll show just a few of them. So in text, a lot of times you'll just see a bold letter. So if you just see bold B, it implies a vector. But on the whiteboard and on paper, when we're writing, it's kind of hard to tell what's being bolded. So sometimes you'll see us write B with an arrow over it. And there is no difference between an arrow or just one of the points, so like a harpoon. All of those mean the same thing. However you want to write it, it's up to you. Those pointy brackets don't mean anything different between square brackets like that. All of those are talking about the same vector. Lastly, you can use that ij notation. So this I vector represents the vector 1, 0. This represents the vector 0, 1. But same thing, however you want to write it. The questions that you'll be presented with could be written in any form. So if we want to find the length of the vector, or the quote-unquote magnitude, then that is going to be the square root of a squared plus b squared. The idea there is we've just got some Pythagorean theorem, length of a, length of b. Well, that means that the length of the vector, doing some Pythagorean theorem, gives me a squared plus b squared. Take the square root. If you want the direction of your vector, just assume that everything's always going to be in that standard position. Standard position meaning our vector points in the positive x-axis, and all of our angles are sweeping in a counterclockwise direction. So we're going to find the arctangent of the y over the x, or b over a in this case. But put a little asterisk there. Just because for some domain issues, arctangent will only give us angles in quadrants 1 and 4. We might have to make some adjustments, and I'll show us an example of that in just 2 seconds. So on the board in that first picture, I drew a vector in standard position, which meant that the vector starts at the origin and ends at the point A comma B. So we only have to think about where the vector ends because we know it starts at the origin. If we don't have a vector that's in that standard position and we're just given 2 points, a starting point and an ending point, then all we have to remember is just final minus initial. Final minus initial. So if I want to find vector A to B, starting at A, ending at B, just remember final minus initial. So I'm going to do the x component minus the x component. Final minus initial. Final minus initial. So this first question wants me to sketch the vector AB in standard form. Again, standard form meaning you start at the origin and end at some point. Well, this component form that we wrote it in is the point where we land. So there's my vector AB. you want to find the length of AB, the same thing as saying find the magnitude. So I get that the length of the vector, if you wanted to annotate on your picture over here, it means that this vector has a magnitude or a length. Next part, find the direction angle. Find the angle in degrees. And find the angle in standard form. Everything we're going to do is always standard form. So again, starting from the positive x-axis, moving counterclockwise. So I get my angle is the arctangent of 1/2. So I'm just going to go ahead and pull out my calculator. I want arctangent or inverse tangent of 1/2. I just want to make sure that I'm in degrees and not radians. Questions? This says given vector u, which is the vector 2, -3, find 2u and sketch both vectors. So we're allowed to scale vectors, meaning multiply by some constant. So if I multiply my vector u by 2, turns out it's not too bad. You just multiply the x component, multiply the y component. So I had my first vector of 2, negative 3. That was vector U. Now when I sketch the vector 2, the takeaway from the picture is that when you're scaling a vector, that is what you're scaling the magnitude by. So whatever I had for magnitude of u, the vector 2u is now quite literally just twice as long. The other thing that's super important that I want you guys to see is the vectors still point in the same direction. I'm not all of a sudden pointing in, slightly off angle. Points in the same direction, now having twice the magnitude. If I multiply by 1/2, then yes, absolutely, my magnitude would now get cut in half. Questions? So given vector v, I'm not even going to give you the components, just a general sketch. On the same coordinate plane, sketch 1/3 of v and sketch negative v. Okay, again, so no components. I'm not trying to find the actual components of the vector. I just want a rough sketch that's roughly 1/3 of v. So I just know it points in the same exact direction, just 1/3 of the magnitude. And now if I want negative v, do you have any suspicions or remember exactly what happens if I scale by a negative? Yep, directly opposite of it. Now if it was negative 2v, then yes, it points in the opposite direction and is double. So in my sketch, it's not perfect. I want to roughly just show that I have the same. if vector A is 3i plus 2j, and maybe we're not a fan of that form, maybe I don't like the i's and j's, I have no problem if you just say, oh, for my scratch work, I'm just going to call this the vector 3, 2. For B, I'm just going to call this the vector negative 2, 6. The first part is to find vector A plus vector B. So mathematically, it's not too bad. It's the way you want to do it. You add the two x components, you add the two y components. I'm sticking with that IJ notation. If you just want to keep it in the pointy brackets, it's totally fine. So you would get 1i plus aj. So we'll keep the same vectors A and B. I can scale vectors. Now we technically can't subtract vectors, but what is something sneaky that I can do instead? Exactly. Technically we can't subtract vectors, but I can add the negative of a vector. So the next thing I would need is a negative of vector B. And now we're good to add these pieces. So I have 11i plus 0j, which I totally agree is just 11i. But if you're using those pointy brackets, we would have to write comma 0. say in this picture we have vectors r and s. So we saw that adding vectors, if you're given the component form, it's not too bad. You just add the x's, add the y's. But I just want to remind us geometrically what happens with these vectors. Who can tell me geometrically, what does it mean if I were to add two vectors together?
Going tip to tail.
It's like the tip to tail idea. You're going to pick this vector up, pick it up all the way, and just drop it, where the tip of the vector is on the tail of the new vector. So I'm just going to pick it up, drop it over here. And you might be wondering, well, how can you do that? Well, don't forget, these vectors in standard form, no matter how I move it around, will always have the same magnitude and direction. So, let's see how good my art skills are. I want to draw something with the same length and points in the same direction as s. This is still the vector s. And you might be going, well, it's technically not, since it's not over there. It is the same vector. They're allowed to live anywhere in space. It's just in standard form if it starts at the origin. And now, the answer that we get when adding the two vectors, what's that vocab word? Starts with an R. That is your resultant vector. So now a good question is, well, hang on. You picked up vector s and dragged it all the way over on vector r. Well, who's to say that you didn't have vector r pick it up and drop it on s? Well, let's see what would happen if we did that. If I now pick up vector r, this vector, move it all the way up and just move it up here, so such that it has the same magnitude, same direction. And you realize that no matter the order that you added in, if you did vector r plus vector s, or vector s plus vector r, you get the same resultant vector. And the idea there is just addition is commutative, it doesn't matter the order that it happens. So you get this fun parallelogram if you were to do both of them at the same time. Last thing for reviewing 2D vectors. Given some sort of vector, find the quote-unquote unit vector pointing in the same direction as v. So in math, anytime you see that word unit, unit circle, unit sphere, it's always talking about one. A unit circle is a circle with radius 1. A unit vector is just a vector of length or magnitude 1. So given some vector v, It's saying find the unit vector that points in the same direction as v. I'll give us just a very quick sketch as to what exactly that means. So this is my vector. The goal is to find a vector that points in the same direction, but now it just has a length of 1. Who can tell me how we're going to get there? Your hint is this idea of scaling over here.
Do you want to find the direction of v first?
Won't we? For instance, with this vector, when we multiplied by 2, we said we just scaled it, so we made it have twice the length. So scaling it plays around with the length of the vector. If I multiplied by 1/2, we said that we're just going to pull the magnitude to be 1/2 of its length. So if my goal is to get a length of 1, essentially I can just find the length of this vector and then divide by what? Divide by the length of the vector. It's however long the vector is, if I divide by that number, I'm going to get 1. So to find your unit vector, you're just going to scale the vector by 1 over the magnitude, is what that's saying.
Magnitude 25, 144.
Now, in our definition, it doesn't show, but basically we're going to have to distribute to each of the components. Working with a nice clean number, it'll help us out. If you have a length of 13, then you just scale it by 1/13. So if you want 1/13 of the size, you'll have a length of 1. So I want the vector that is 1/13 of the length. And the last thing that we want to do is just multiply through to each of the components.
Nice. Makes sense.
Questions? But we're here to talk about vectors in 3 dimensions. Now, for the purposes of today's class, the better news about 3D vectors, it's the same. Everything's the same. Some things might be tweaked a little bit, but this is going to feel very, very, very familiar to 2D vectors. just something worth mentioning that I noticed when drawing this. I always said that I'm gonna label the positive axes. I found in my sketches that if I don't draw the arrows on the negative ones, it just helps me see it clearer. So when I see the arrow, my brain just goes, okay, that's the positive axis. And this is more just to create some sort of imaging. So extending to 3 dimensions for vectors, you just now have a z component. X component, y component, z component. So here, instead of having ij, you have ijk. And yes, attempting to draw these vectors in 3 dimensions is a menace. Let me try. The only thing that really changes for us is now when you're finding the length or the magnitude of the vector, it's just going to be the square root of x squared plus y squared plus now z squared. Talking about angles are going to be a little bit different and something we'll talk about next time. Because in the past we just talked about the angle from the positive x-axis, but now I've got kind of multiple angles. It's how far I swung out this way, and now how far you're swinging out from multiple axes. All right, so for these problems, you get a minor mark. You guys are more than welcome to work on the board. I'm going to step right next door and get some markers for you guys.
A copy for me.
Yes. They are. Alright, go ahead and stand up, grab a marker, grab a chunk of board. Find someone to work with. You guys can raise hands. Say again? So you're starting that.